Now we want to go ahead and work on solving some equations with the log in it. And in this case, and we'll talk about this later on, you notice it's just going to be one term with a logarithm in it. And so here's how we solve them. For instance, let's just write down one of these problems and we'll talk about it for a minute. X equals log 27, log base 27 of 3. The way we're going to solve this, easiest way, until maybe you become very comfortable with logs or have a really good feel for them, for most of us, the way we're going to do it is I'm going to convert this logarithmic equation into an exponential equation. Because when I have this written as an exponent, or an equation with an exponent, I'm probably going to be able to solve it. And now I'm going to use my shortcut. In this case, you start with the base. And in this case, since it's written like this, you always sort of go across the equal sign, and then you circle back around. So basically, to write this as an exponent, 27 to the x equals 3. Now here's where you have to have a little bit of a feel for exponents, because now we're saying, what is the exponent? What is x going to be to make this equation true? And then you realize that, either you realize to yourself that, 27 equals 3 cubed. And there's actually two ways to go about solving this. I could go ahead and say 27 is 3 cubed. So 3 cubed x equals 3. This becomes 3 to the 3x equals 3. And really, if you want to, you can think of that as being 3 to the first. So you know that 3x equals 1. Therefore, x is 1/3. Or, a lot of you, if you have a pretty good feel for especially rational exponents, when you see this, you say, what does the exponent have to be on 27 to get it equal to 3? And then maybe a lot of you realize, well, basically, the cube root of 27 is 3. Another way to write the cube root is to write as 27 to the 1/3. So therefore, x equals 1/3. All right, that one was a little tricky. How about log base x of 9 equals 1/2? Well, start with x, going to go across the equal sign and then back around. So x to the 1/2 equals 9. X to the 1/2, hopefully you realize is the same thing as square root. So you say the square root of what equals 9? And hopefully you realize it's 81. All right, let's do another. Some of these can get pretty tricky. How about log base x of 125 equals -2. So once again, let's write this as an exponent. Go to the right and then circle back around, and we have x to the -2 equals 125. And now, of course, we have a negative exponent, which I want to get rid of. So I can rewrite this as 1 over x squared equals 1 over 25. And then it becomes pretty obvious that x squared equals 25. And we're just going to take the positive root. So x equals 5. All right, let's do a couple more. Now we have some that involves a little bit of algebra, maybe. How about this one? Log base 4 of 2x plus 4 equals 3. All right, so here's an equation where we have a log, and we only have one term with the log in it. So we're going to use our little shortcut and write this as an exponent. 4 to the third equals 2x plus 4. 4 to the third is 64. 64 equals 2x plus 4. We subtract 4 from both sides. 60 equals 2x. Looks like x equals 30. Now the one rule, which I haven't really talked about, which I sort of neglected, was that whenever you solve an equation with a log, you always have to check your work. Because sometimes with logs you'll get extraneous solutions that don't really work. So in this case, if I plug 30 back into my original equation, so I'd have log base 4, 64 equals 3. And just to see if that makes sense, I write that as an exponent. Does 4 to the 30 equal 64? Yes, it does. So there are some examples of solving an equation where you have a log. And the whole key is you simply rewrite the log equation as an exponential equation, and usually we're able to solve the problem.